Hello aspirants, welcome to Loka and IS Academy. My name is Praveen Akkanauru and we have started looking at the CSAT PYQs and we have seen some basic chapters before that. So just go through those videos also. I have covered many basic things which are related to our CSAT papers because quantitative aptitude is the biggest chunk. Last year 37 questions were asked and previous to that year there were also around 35 questions based on these topics, quant topics, right? And questions are mostly of basic nature. Your basic knowledge is tested in every question, right? So today we are going to look at SURDES and indices. We have all learned it in 7th or 8th standard, but just refresh our memory and try to remember some rules related to SURDES and indices. Now indices, when I say index, indices is the plural for index, right? So when I say index, a to the power m. So m is called index, a is called base, right? So there are few rules, right? If a to the power m into a to the power n, that means multiplication of two numbers where base are equal and indices are different. At that time there is sum of indices takes place. A to the power m plus n, right? Similarly, if there is division, a to the power m divided by a to the power n, then subtraction of the indices takes place, right? If a to the power m and whole bracket n, then a to the power m into n, right? Again, if a to the power minus m, so to remove this minus sign, I can take it into denominator. And for any number, if power is 0, the value becomes 1. So these are some basic formulas related to SURDES and indices. So just let's go through some typical problems that UPSC asks, right? So which number amongst 2 to the power 40, 3 to the power 21, 4 to the power 18 and 8 to the power 12 is the smallest? Which of these which of these numbers is the smallest? Now look at all these numbers. Bases are different, 2, 3, 4, 8. Indices are different, 40, 21, 18, 12. So is it a bit difficult to decide which number is the greatest and which is the smallest? If they have asked us 2 to the power 40, 2 to the power 35 and 2 to the power 50. So it was easier because when base is same, whichever has index bigger, that number will be greater, right? But here bases are different, indices are different. So we have to at least make their base equal or at least make their index equal. So let's check what we can do here. 2 to the power 40, 321. Now let's look at these numbers, 2, 4, 8. All these numbers are multiple of 2. So I can convert these numbers into 2. So 2 to the power 40 as it is, 3 to the power 21. This 4 I can write as 2 square and to the power 18. This 8 I can write as 2 cube to the power 12. So 2 to the power 40, 3 to the power 21, 2 to the power 18 into 2, 36. To the power 36 and again 2 to the power 36, right? Here lies your answer. No need to go further. Why? Because 2 to the power 40 is bigger than 2 to the power 36 and 2 to the power 36. So this is a bigger number. So this cannot be our answer because we need the smallest number. So this cannot be our answer. And if these two numbers are equal, how can they be the smallest? If these two numbers are equal, how can they be smallest? So these two numbers are not going to be smallest. So answer is 3 to the power 21. Option number B. No need to go further. No need to do any further calculations. Right? Because I got the bases equal 2, 2, 2. So just by comparing their indices, I can decide 2 to the power 40 is the bigger number than this one and then this one, and these two numbers are equal, so they are not going to be the smallest, right? So answer will be 3 to the power 21. Next question, 15 into 14 into 13 into up to 3 into 2 into 1 is equal to 3 to the power m into n, where m and n are positive integers. Then what is the maximum value of m? They have just expressed left side in the form of 3 to the power m into n. It is a power of 3, that means multiple of 3. So I have to just find those numbers which are multiples of 3 on the left side. Which are those numbers? 15, 12, 9, 6 and 3. 15 is what? 3 into 5. 12 is what? 3 into 4. 9 is what? 3 into 2. 6 is what? 3 into 2. And 3 is what? 3 into 1. So how many times I got 3? 1, 2, 3, 4, 5. Sorry, this should be 3 into 3. So 1, 2, 3, 4, 5, 6. So 3 to the power 6 into whatever number that is remaining, that will be the multiplication. That means it is n. So there is no need to find n. I am just asked to find the value for m, and the value for m is 6. Because I got that in the form of 3 to the power 6. And they have given in the form of 3 to the power m. So m becomes 6. So answer will be option number B, that is 6. This is also an interesting question. If 3 to the power 2019 is divided by 10, then what is the remainder? Now there are two things. One thing is this expression or this term or this number 3 to the power 2019. Is it manually possible to find the value for 3 to the power 2019? No, it is manually very difficult, but I do not need to find whole value, right? Because they have asked when this number is divided by 10, what is the remainder? Now take any number, say 125. When I divide it by 10, so what will be the remainder here? Remainder will be 5, because 10 ones are 10, 2 remaining, 20, it becomes 25, 10 twos are 20, remainder is 5. So 5 is the remainder. When I divide 1, 2, 3, 7, 9 by 10, I got remainder as 9. So whenever I divide any number, I get remainder equal to the unit place. I get remainder which is equal to the unit place of that number. So I just need to find unit place of this number. So I just need to find unit place of this number. So that unit place will be the remainder when I divide this number by 10. That unit place will be my answer. Now how to find unit place? How to find unit place of such big number? 3 to the power 201. Tell me what is 3 to the power 1? It is 3. What is 3 square? It is 9. What is 3 cube? It is 27. What is 3 to the power 4? It is 81. Right? So when I am taking powers of 3, that means I am just multiplying the answer with 3. 3 into 3, 9. 3 into 9, 27. 3 into 7, unit place will be 1. What will be 3 to the power 5? Again I will have to multiply 81 with 3. So unit place will be 3. 3 to the power 6, unit place will be 9. 3 to the power 7, unit place will be 27 or 7. 3 to the power 8, unit place will be 1. So look at the unit places. 3971, 3971, they are repeating. They are repeating. After every 4 times, they are repeating themselves. That means if 3 to the power 4 gets unit place 1, 3 to the power 8 will get unit plus 1, 3 to the power 24 will get unit plus 1. So just tell me the closest number or number before 2019 which is divisible by 4. that number will be 3 to the power 2016. At that time, I'll get unit place as 1. At that time, I'll get unit place as 1 because the power is divisible by 4 or power is a multiple of 4. So at that time, I'll get unit place 1. So next iteration will be 3 to the power 2017 will give me unit place as 3. 3 to the power 2018 will give me unit place as 9. 3 to the power 2018 will give unit place me as 7. Right? I want this unit place. I wanted this unit place. 3 to the power 2019 gives me unit place as 7. If unit place is 7 of this number, then when it is divisible by 10, I'll get remainder as 7 only. So answer will be option number C, that is 7. I hope you understand the logic behind it. And this is the simplest trick to solve such questions. Many times they will ask you what will be directly they will ask you what will be the unit place of 7 to the power 579. So just find the pattern of 7's power and when they are repeating themselves. So they will give, sometimes they will ask you 7 to the power 759 into 9 to the power 121. And what will be the unit place of the multiplication? Suppose this gives you unit place 9, this gives you unit place as 1, so multiplication will be 9. So in this way, you can find the answers. What is the largest number among the following? Just a while ago, I told you a rule. When the power is negative, just take the reciprocal of that number. Just take the reciprocal of that number. That will give you the power in positive terms, right? Reciprocal means what? Interchanging your numerator and denominator. So if all the powers in the given options are negative, so to make them positive, I have to just take reciprocal of 1 by 2. So it becomes 2 and the power becomes positive. It becomes 4 and the power becomes positive. It becomes 1 by 3 becomes 3, power becomes positive. 1 by 6 becomes 6, power becomes positive. So these values I can calculate. 2 to the power 6 is 2, 4, 8, 16, 32, 64. 2 to the power 6 is 64. 4 cube becomes 64. 3 to the power 4 becomes 3, 9, 27, 81. And 6 square becomes 36. So what is the question? What is the largest number? Largest number is 81 here. So option number C. 1 by 3 to the power minus 4 is the largest number here. So understood? It is based on very, very basic formula that I just told you. A to the power minus m. To make the power positive, I have to take the reciprocal of this number or this base and the power becomes positive. So next question from SURDES and indices is, for what value of n the sum of digits in the number, for what value of n sum of digits, pay attention, for what value of n the sum of digits in the number 10 to the power n plus 1 is 2. For what value of n? For n is equal to 0 only, extreme statement. Just keep value for n as 0, it becomes 10 to the power 0 plus 1. So any number if it has power 0, that value becomes 1. So 1 plus 1 is equal to 2. So sum became 2, right? Sum of digits is 2. That is correct. But is it only possible when n is equal to 0? If I keep n as 1, 10 to the power 1 plus 1. So it becomes 10 plus 1. It becomes 11 and sum of digits become 2. 1 plus 1 is 2. So it is true for 1 also. If I keep n as 1, then also 2. So this statement is partially right, but not entirely right. For any whole number n, for whole number, basic concept, what are whole number? 0, 1, 2, 3, 4, up to n. right? We have checked it for 0, we have checked it for 1. Let's check it for 3. 10 to the power n, 10 to the power 3 plus 1. So 10 to the power 3 became 1000 plus 1 becomes 1001. So sum of digits become 1 plus 1, 2. So again sum of digits is 2. So for any whole number n, it is correct. For any positive integer n only, third option. Any positive integer means they are not considering 0. 0 is neither positive nor negative. So they are not considering 0. So this is wrong. For any real number n, no. Real number means what? Real number consists of all the numbers. They consist of rational, they consist irrational, everything. So if I put n is equal to 3.14, that is irrational number. So whether I will get the same value, that is the addition of numbers as 2, no. Addition of digits 2, no. So option number B is correct. For any whole number n, the value for this 10 to the power n plus 1 is always true. For any whole number n. Because whole number consists of 0 also and as well as positive integers also. Right? So these are few examples from SURDES and indices. And in next video, we will cover some more basic chapters as well as some reasoning chapters also. So stay tuned and just wait for the video and practice through the PYQs only, because time is less and this is the best way to conquer the CSAT paper. So thank you.